All right, everybody. Today we are looking at how to apply Ohm's law to a circuit. That means we're also going to be looking at equivalent resistances for resistors either in series or in parallel. So what we're looking at here is the question, what is the current in a circuit if a 9-volt battery is connected to two 3-ohm resistors in series, or what if it's parallel? So what we're looking for is, in both cases, current. There's current for series and there's current for parallel. What we know is we've got a 9-volt source, so our voltage is 9 volts. We know our resistors are 3 ohms. We know that if we've got resistance and voltage, we're going to use Ohm's law, current equals voltage over resistance. And we also have two new equations for the equivalent resistance of circuits. One for series is just Req equals R1 plus R2. And the other is Req for parallel. This is the confusing one that was in the book. This is the one that is R1 times R2 over R1 plus R2. Looking at part 3 for our sketch, now we do have a sketch, and this is where the schematic diagram drawing comes into play. So in the first case, what we have is we've got a voltage source, we've got two resistors. Whenever we're labeling this, we want to label these things either on above or outside of the diagram if it's on the side. So in this case, this is the battery symbol, so we've got 9 volts, 9 volts, and these are our resistors of both 3 ohms. The other setup, this is for the series. For a parallel setup, what we have is, we've still got our major setup here, or should say, we've still got our voltage source up at the top of 9 volts. Then we've got these two lines running in parallel to each other. So this is now going to be 3 ohms and 3 ohms. Before we can get to the current, we need to know what is the equivalent resistance. For this, the equivalent resistance is just the sum of these two. So we've got 3 ohms plus 3 ohms, which is 6 ohms. Here now we use the Req equals R1 over R2, R1 times R2, I should say, over R1 plus R2. So our equivalent resistance will be 3 ohms times 3 ohms over 3 ohms plus 3 ohms, which in this case is going to be 9 ohms squared over 6 ohms. These units right here, 1 ohm up top cancels with 1 ohm on the bottom. So this is, if I reduce this down, 3 halves of ohms times ohms over ohms. Two of these cancel and we're left with 1.5 ohms. From this point now, it's just using Ohm's law from last week. The current will be the voltage over the resistance. So current equals 9 volts over 6 ohms, which in this case is going to be 1.5 amps. Over here, we're going to have current equals 9 volts over 1.5 ohms, which is 6 amps. A lot of the math is the same. The only thing we really have to watch out for is when we're dealing with the equivalent resistance for parallel circuits. This is where it gets tricky. Series, it's going to work basically just like your intuition thinks. You add them all up together. Here, because we've got the multiple pathways and we're splitting apart, we have to deal with this a little bit differently. We'll talk all about that at our Zoom lecture on Wednesday, but this will be enough to get you through the supplement and what we're looking for this week. All right, thank you very much. I hope you have a good day.